This is video number 1 for Math107 for the sample exam for chapter number 7. Remember that there is no exam on chapter 6. The exam starts off with factorials. So you're given an expression involving factorials in the numerator, factorials in the denominator, and the variable m gets to be replaced by 4. So put the 4 in the parentheses, work the inside parentheses out first to get your 8. Okay, you don't distribute the factorial sign through the parentheses. So you have 8 factorial in the numerator. In the denominator you have 4 minus 4 factorial. This is 0 factorial. Now you can't divide by 0 itself, but you can divide by 0 factorial because 0 factorial is equal to 1. And that's why 0 factorial is replaced by 1. You never have to work out 8 factorial on any exam. There will be no calculator as usual. If you stop right here at this point with the 8 factorial over 1, which you could write as 8 factorial, then you're done. All your math, all the arithmetic, all the uses of the factorial is done, and this would just be an evaluation of 8 times 7 times 6 times 5, 4, 3, 2, 1, etc. Okay, here's the second one. N factorial over 3 factorial times n minus 2 factorial, and n is going to be 7. So you put 7 in to this equation, so it's 7 factorial in the numerator. The denominator, I'll write it over here, is up 3 factorial times 5 factorial. These are separate calculations, and when you work them out, they really would be in parentheses. But you can use the 7 factorial to do some elimination. You can count down on the 7 factorial till you get to 5, and then everything beneath that is written as 5 factorial, which cancels this 5 factorial. Now in the next step, which isn't written there, I'll write it here. I have 7 times 6 divided by 3 factorial. There's nothing to do. There's nothing to cancel against. You just have to expand the 3 factorial. 7 times 6 over 3 times 2 times 1. And then work out the arithmetic. In this case, it's so simple you should do it. On the actual test, you are given the binomial theorem. You don't have to remember it, but you have to know how it goes. All right. Then you're given something a little bit harder to work out, and it is actually broken down. If you have something raised to a binomial raised to the 3rd power, first expand as though it's a plus b. That's the only way you can use this formula unless you use a whole lot of parentheses. Okay, so a plus b to the 3rd power is, and you just substitute right through here. You see the n is 3, so you see the 3's, 3 here. And remember that as a counts down, b counts up, and the sum of the exponents is always 3. The exponent on b, of course, is 1, so 2 plus 1 is 3, and here you have the 1 and 2, which is 3. 3 by itself is 3. So the sum of the exponents on the variables is always 3. To find the coefficients, you construct these fractions, and the numerator of each is the 3 factorial. The denominator are the 2 exponents factorial. So there's a 1 factorial here, oops, right here on the b. That appears down here as 1 factorial. The 2, actually, when it's written in this generality, that's just how it has to be written. But what it ends up being, you can see right here. Here's the exponent, n minus 1. It appears down here as n minus 1 factorial. This has an exponent 1. It appears down here as 1 factorial. Go to the next one. This 2 is an exponent, 2 factorial down here. N minus 2 is an exponent, n minus 2 factorial down here. Then you work it out, and for this case, a plus b raised to the 3rd power is a cubed plus 3a squared b plus 3ab squared plus b cubed. Now go back to your problem and make an identification. A is 2x, b is negative 3y. And you go through this form, every place there's an a, you put 2x in parentheses. Every place there's a b, you put minus 3y in parentheses. And you get an expression that looks like this. The big mistake that happens here is people see this negative sign, for example, right here, and think it's a subtraction. It's not. It's multiplication. Also remember to use the parentheses because here the a is cubed, but now that the a is 2x, the whole 2x is cubed. When you cube that, you get 8x cubed because you had to cube the 2 as well as the x. Go to the next term, you'll have 3, and then squaring all this is 4x squared times the negative 3 gives you negative 36x squared y. You can keep working through the coefficients here, noting that your symmetry, the nice symmetry that you see in the binomial theorem when you have a plus b, that's gone. For the sigma notation, sigma is for sum or addition. And the factorial that we were looking at a minute ago has to do with multiplication. With the sigma notation, there's certain rules. First, for the notation itself, this is the starting value is placed underneath the sigma, and the value on the top is the maximum value for the counter. In this case, our counter is k, and the expression is 3k squared. Now, if there's a constant, in this case the 3, that multiplies everything, it can be put, in a sense, factored out. So it becomes out here. And the next trick is just to remember to use parentheses because the 3 multiplies everything. So it's 3, put your parentheses, times 0 squared, 1 squared, 2 squared, keep advancing the counter until you get to its maximum value of 4 squared. Oh, very interesting. This needed a 4 squared in here, didn't it? Okay. Because you start at 0 and go to the maximum. In this case, it's a 4. Okay, let me start this next section by saying there will be absolutely no matching on the test. I don't know why I put this on the test, and I've left it here on the sample test, although I've taken it off the actual test many semesters ago. But I put it on here just so you can practice with the recursive definition, but there are no matching. I don't know what I was thinking of. I don't like matching. Okay, what does a recursive definition do? In this case, it gives you the first term. The first term is going to be 2 in this sequence. Remember, a sequence is an ordered list of values, ordered list of numbers. Okay, then it gives you a rule. I can find the next one as 2 times the previous one. The counter has a little bit of arithmetic associated with it. You can see that right now. If a was 3, if n was 3, then this would be 2 times a. 3 minus 1 would be 2. So the next one in the list is twice the previous one in the list. That's just what this rule says. Now let's write the sequence from that. So a1 is 2. That's given. a2 is 2 times a1, so it's 4. a3 is 2 times a2, that would be 8. a4 would be 2 times a3, and I got all this information from this recursive definition. I'm going to go through the others because I think sometimes people have trouble with these. Okay, a1 is 1, we're told that. Then the new one equals twice the previous one minus 1. So we'll work this out. a1 is 1, that's given. a2 is going to be 2 times a1 minus 1. Well, that's a1 is 1, so that's 2 minus 1. That's going to be 1 also. How about a3? a3 is going to be 2 times a2 minus 1. Well, that looks like that's going to be 1 again. So it's possible you have a whole bunch of 1s, but okay. a4 is twice a3 minus 1, so again you get a 1. There's no big significance to these sequences that we're listing here. Is just practice with recursive definitions. Okay, where were we? a1 was 2. The new one is the old one, an minus 1 squared. So a1 is 2. a2 is a1 squared, which would be 2 squared, or it's 4. a3 is going to be a2 squared, So that's 4 squared, 16. Keep going like that. I hope you're seeing this notation. A1 is 2. Okay, and I say the new one, or the next one, is the previous one with 2 added onto it. So I can write the terms. A1 is 2. A2 is going to be A1 plus 2. It's going to be 4. A3 is going to be whatever A2 was, 4. Added 2 to it gives me 6. A4 is A3 plus 2, so 6 plus 2 is 8. On the final one there is every term multiplied by 5. Okay. In this case, you're given the sequence, and you are required to define the sequence recursively. That means write the little formulas that give you, that let you compute the next term in terms of the previous terms. So there's 2 ways to do it because, first you have to recognize what's going on in the sequence. Here there's a common difference between every one of the terms, 4. 1 to 5 is 4, 5 to 9 is 4, 9 to 13 is 4. Okay, so it's 4. This is an arithmetic sequence and with a common difference of 4. There's actually 2 ways to write an arithmetic sequence. The first way is similar to the ones on the other page. Specify the first term. A1 is 1. Specify how to get the new term in terms of the old ones. Well, the next term is the previous term with 4. You're done. N greater than 1. Okay? There's a second way where these can all be wrapped up together, and it can be done this way only because it's an arithmetic sequence, and it's given right here. The next one is the first one plus the common difference times n minus 1.